chemical properties of water. Whenever you hear chemical properties, what should come to your mind is the reactions that whatever it is that you are talking about undergoes. So what are the reactions that water undergo? And of course, in chemistry, we'll check, does that thing react with metals? How do they react? Does it react with non-metals? How do they react? And if it's not water, does it react with water? Are you seeing it now? But here we are talking about water. So we'll check, does it react with metals? And these metals are grouped into different types. We have the active metals, we have the the reactive metals, very reactive metals. We have the not as reactive as the one, and then we have the metals that are not reactive at all. So let us see how they go with water. So with highly reactive elements, highly reactive metals, for instance, you have sodium, potassium, and the calcium. So when we are looking at this, they react violently with cold water. In fact, when you are reacting with sodium and potassium, you have to be very careful. They react very violently, as in the reaction is so violent that it can lead to corrosion if that thing touches you. And the reaction is exothermic. That is, it produces heat at the end of the reaction. When you touch the back of the, let's say the beaker, whatever you're using to do the reaction, you see that it is warm or hot. Okay, so now I want to give you the trick now. First, remember when I was talking about writing of equations, I said something that the reactants and the products are the same elements in different combination. Now, if I am reacting with water, it means that one of the reactants is water. And if I'm reacting this water with a particular type of element, you already know if you've seen your activity series, you see sodium and the rest, and just it's simple, just note it. Sodium and potassium are very reactive. In the first 20 elements, potassium is the most reactive, followed by sodium. Okay, so you see that these three elements are the most reactive compared to other metals. So because of their level of reactivity, in terms of water, they react with cold water. Why is it cold water? Cold water does not have as much kinetic energy or strength of reaction as, let's say, steam. Remember when you did a kinetic theory of matter, when it has to do with the movement of solid, liquid, and gas. Of course, cold water is liquid, therefore it does not have as much kinetic energy as steam. And when you did your collision theory and about reaction, you notice that the more the reactant particles collide with each other, the possibility of forming products. So if this particular one reacts with water that is not even hot, cold water, it means that it is so reactive that even if the water does not have as much energy as steam, it will still react. I don't know if you get. So because of their high reactivity, they react violently with cold water. That's all this English I'm speaking. That's what I'm trying to say. And then when it comes to writing the equation, remember I said, you already know the reactants. So if the reactants is, let's say, a reaction with sodium plus water. Sodium is solid. Water, remember we said is cold water, so it's liquid. I say that. Now the products, of course, sodium will be part of the product. So we write down our sodium. But then how does it combine? It combines to yield alkalis. So and liberate hydrogen. It yields alkalis and liberates what? Hydrogen. So we need to note that. You need to note this because it's quite simple. This equation is very simple. Sodium. You already know that, of course, for a base we have what? The hydroxyl ion and the hydroxide ion. Then what will be left is hydrogen. You can't write hydrogen without putting 2 there because one single atom of hydrogen cannot stand on its own. Remember I taught you how to write equations, so I want you to note that so you don't make mistakes while writing them. Now look at the equation and check, is it balanced? We have an atom of sodium here, we have an atom of sodium here. We have an atom of oxygen here, we have an atom of oxygen here. We have 2 atoms of hydrogen here, but we have 3 atoms of hydrogen here. So how do we balance it? So let's say, when this is odd number, I always say even out. It's always good to even out so it will be easy to balance. Because if I say, this is 3, let me put 3 here, you will balance this thing till eternity. So this one that made it an odd number, I'll try to even it out by putting 2 here. So my putting 2 here makes sodium 2, so I'll put 2 here for sodium. And my putting 2 here makes oxygen 2, so I'll put 2 here for oxygen. So let's check it again, of course, because the moment I put 2 here for oxygen, this 2 is also for hydrogen. So 2 times 2 is 4 atoms of hydrogen. And let's see for this hydrogen, 2 times this is already 2 plus 2, 4 atoms of hydrogen, 2 sodium, 2 sodium, 2 oxygen, 2 oxygen. So our equation is balanced. Is that clear? Alright, so let's write, in case for potassium, the equation for potassium will look the same. Reason, potassium has the same valency as sodium. So if I want to replace, this is capital K. I cannot come and break my phone. So if I want to replace sodium with potassium, it's very easy. I don't need to change anything. So let me do just that. Because they have the same valency, they have a valency of 1. So they have very similar chemical equations. And like I said, the 2 of them react violently with water to liberate hydrogen. So let's say you are looking at a chemical reaction and the equation goes like, which of these metals will liberate hydrogen from water? Which of these metals will liberate hydrogen in reaction with cold water? And you see other metals are probably, they don't react with cold water. You see, let's say you see something like iron in the options, you see gold, you see lithium or beryllium, then you see potassium. Of course, the answer is potassium. Okay, so this is what it's all about. So for calcium, which has a different valency, I'll have an equation that looks like this. Calcium solid plus water. Remember, the moment you are told, you already know what the equation, the reactant will look like. So we have our calcium and hydroxide, of course. We exchange valency. The valency of calcium is 2. The valency of hydroxide is 1. So when we exchange the valency, the hydroxide being a radical has 2. Because it's a radical, we have to put the bracket to indicate that the 2 is for both oxygen and hydrogen because it's a radical. And like I said in previous classes, a radical is a group of elements that act as a single unit. So because this hydroxy ion is a single unit, they have a single valency which is being exchanged. So the hydroxy ion as a group has a valency of 1. Calcium has a valency of 2. When they exchange the valency, we put this bracket and then put 2 to show. Of course, this has a valency of 1. We don't write 1. So this is the correct formula for calcium hydroxide. And then plus our hydrogen that is to be liberated. and the hydrogen gas. And this is in aqueous solution, of course. So how do we balance the equation? Let's see if it's balanced. Calcium, calcium, 1 oxygen, 1 oxygen, 3 hydrogen, 2 hydrogen. Oh, sorry, not 1 oxygen, 2 oxygens, sorry. 2 oxygens, 2 hydrogen plus 2 hydrogen, that's 4 hydrogen and 2 here. So let's put 2 here and see what happens. So we have 4 hydrogen, 2 oxygen, 2 oxygen. The 2 oxygen, remember this 2 here governs both this and this. Okay, so that's the balanced chemical equation for the reaction of calcium and water to produce calcium hydroxide and liberate hydrogen gas. So that's it. All right, then the next one is for highly reactive metals, very active. We call them active metals or highly reactive metals. So for less reactive metals, less reactive metals, we have metals like magnesium, aluminum, zinc, iron. These ones, they do not react with cold water. You know, I've given you my reason. Sodium, potassium, and calcium will react with cold water because they themselves are very reactive. So they can easily react with anything. Okay? But then, these other ones, we have magnesium, we have aluminum, we have iron, we have zinc. These are not as reactive as the first ones, so they do not react with cold water. They only react with steam. So this is water, but this is gaseous water. Because remember what I talked about in the kinetic theory. Because the state of the gas enables it to be able to, react with these less reactive metals. So we have an iron actually reacts reversibly with the metal, and when they react, they do not produce alkali. No, they don't produce alkali. They actually produce the oxide of the metal. What do I mean? If you already understand which one is which, you will know the products that you will get. You understand? All these things are actually supposed to be what you experiment in the lab. You will now test to know what is produced so that you will know. But here we are doing it theory. So you have to know what you expect, so you know what to write. In the first ones, they are highly reactive, so they produce alkalis and liberate hydrogen. In these less reactive ones, they do not react with cold water. They react only with steam, and they produce the oxide of the metal, and also, of course, liberate hydrogen. So here we have, let's say, magnesium. Magnesium is solid, of course, plus water. Please note that if you write this thing like this without putting the states, nobody will mark it for you. Reason. It is stated clearly that magnesium does not react with cold water. They only react with steam. So it is of paramount importance that you must put the states. Must. You can even write steam under it. Do you get? So that you don't say, but I don't want that. You have to put the state because of the fact that this cannot react with ordinary water. So magnesium reacting with steam, so give us magnesium oxide and liberate hydrogen. Okay. So let's see if it's okay. Magnesium has a valency of 2, oxygen valency of 2, so 2 cancel 2. So this is a correct chemical equation. Let's see if it's balanced. one magnesium, two hydrogen, one oxygen, one oxygen. It is very, very balanced. Okay, and this is a type of oxide. This is a type of oxide that when it dissolves in water, it liberates hydrogen. Scrap that. What type of oxide is this? I want your answer in the comment section, and I have a token for whoever gets the correct answer. What type of oxide is this? So in the same vein, all these other ones also react to yield the oxide of the metal and liberate hydrogen. So let's look at something like aluminium. Aluminium. Zinc will look like this, because zinc also uses a valency of 2. So I won't be writing that of zinc. So let's look at aluminium. So, of course, we have aluminium oxide. But let's see what the correct chemical equation should look like. So we have oxygen has a valency of 2, aluminium has a valency of 3. So we exchange their valency. We have Al2O3. So that's the correct equation for that of aluminium. So let's balance the equation. We have 2 aluminium here, so we have to put 2 here to balance that. While we have 3 oxygen here, but we have only 1 oxygen here. So if we put 3 here, we have, the reason I put 3 there is because I can see that hydrogen is staying on its own, so I can easily add anything to balance it out. You get? So we have 3 atoms of oxygen and 6 atoms of hydrogen. So what do we do here to make this 6? We put 3. Alright, so I think it's balanced. 2 aluminium, 3 oxygen, 3 oxygen, 6 hydrogen, 6 hydrogen. And another thing, balancing of equation, if your equation cannot balance, the truth is that your equation might be wrong. If you have, if you are really good at balancing equation, but equation could not balance, it can only mean that your equation is wrong. So take note of